Welcome back to Let's Understand Mathematics. In this video, I'm going to be taking a look at fractional exponents. We'll be continuing on from what we looked at in part 1. In part 1, we looked at unit fractions. So unit fractions meaning the fractional exponents are unit fractions. Unit fractions, if you don't know them already, numerator equals 1. So like 1/3, 1/2, 1/8, etc. In this video, we're going to be looking at complicated fractions like, for example, 2/3, 3/4, and like fractions where we're dealing with the numerator does not equal 0 or 1. Okay, so without further ado, let's get into the lecture. So as you haven't already recalled, a to the power 1 over n, this is a unit fraction. So unit fraction, so in that case we take the nth root of a. I've showed it to you in part 1. The description will have that video for you. So now we'll go to this one, which is a to the power of k over n. K over n. So k now represents the numerator, and k represents any positive or negative integer, whole number, except for 0 and 1, because if we had a 0 in the numerator, it would be a to the power of 0, which would give you 1. So this rule won't apply, and a to the power of 1 in the numerator will just be the same as the top, so this rule won't apply. So therefore k cannot equal 0 and 1. And let n represent any positive or negative integer, and a, but make sure both of them, both k and n, are not negative, because if they're both negative, it would be a positive fraction. So either one of them has to be negative, either k or n. And then let a represent any real number, so any number. So in that case, when you're looking at a to the power of k over n, would you be in agreement, would you agree with me that a to the power of k over n equals a to the power of k bracket raised to the power 1 over n? Remember our laws of exponents. This is the power to a power rule. Power to a power rule. So in that case, when we're dealing with power to a power rule, what do? We have one base, we have two exponents, and we're taking the power to a power. So in that case, we multiply the exponents. So remember what we did in multiplying fractions? K times 1, k, a to the power of k times 1 over n. So we multiply the numerators. K times 1, k, 1 times n, n. So a to the power of k over n equals a to the k over n. So we know that they both are equivalent in value, and we've expressed it in two different ways. So now that we've expressed it into two different ways, and we know that they are equal, notice that now we have a unit fraction, but instead of a, we have a to the power of k. So if you look at this, doesn't it look similar to this? Here we're taking a to the power of 1 over n. Here now we're taking a to the power of k bracket, and then we're raising that to the power of 1 over n. So basically we're doing what we did for unit fractions now. So when we have a unit fraction, we're taking the nth root as in whatever says in the n of our denominator of our unit fraction in the exponent, to the power of a over k. So that is how the rule is sort of derived. So I've showed it to you here. So a to the power of k over n, we're now taking the nth root of a to the power raised to the power of the numerator. So that is how we do it. So let me show you one example. So 64 to the power of 2 over 3. Okay, so I've already showed you that 64 to the power of 2 squared to the 1 over 3 equals the same. So a raised to the power of k, and that raised to the power of 1 over n will equal this, right? Because we're multiplying the exponents. We multiply the exponents, you get 2, and then 2, and then 3 in the new denominator. So 64 to the power of 2 over 3, you get that here. So what do we do now? So now we are taking the nth root. So nth root is indicated from the n value in your denominator. So the third root or the cube root, the cube root of 64 squared. So 64 squared is 64 times 64. You get 4096. You get 4096. Now you're looking at the cube root of 4096, okay? So cube root, I already showed you the concept of root in the last video, but I just want to show it again. So we have, what was it? This 4096 to the power of 1 over 3, which are also equal to the cube root of, 4096. I just represented it in a different way. So base to the power of 3. We know how many, so we have a base now. We have an unknown base now. We know how many times we have to multiply it by itself. And we also know what our result will be, which is the 4096. And the 3, the n, we know how many times we're multiplying the base by itself. It comes from the n value of our unit fraction here. So base to the power of 3 equals 4096, okay? So we know that. So now we have to figure out our base. We're doing the opposite operation. So that is the root. So we do the cube root now. Cube root, this will cancel out, this will cancel out. Base is by itself, is isolated. What we do to one side, we do to another side. So base equals the cube root of 4096. So base equals 16. So we know that if we plug into your calculator, you know that 16 times 16 times 16 will give you 4096. Therefore, 64 to the power of 2/3. Let me write that a bit smaller. Equals 16. Okay, so therefore, we know based on solving all this and just adding that second step, for complicated fractions like 2/3, 3/4, we are taking the base to the power of the numerator, and then we're raising that to the power of 1 over n, which is 1 over the denominator of k over n. So that being said, that concludes fractional exponents. Thank you very much for taking the time to watch the video. We'll see each other in the next video. Thank you.